Good morning, everybody. We are looking at section 2.6. Again, it says 3.6, but we're talking about constructing parallel and perpendicular lines. We're familiar with both terms, so this is going to be just a situation where we're building upon what we already know about parallel and perpendicular lines and developing a deeper understanding of how some of these things are related, especially when we talk about transversals and things like that. With the first section here, 1 and 2, we're looking at true and false. It says a rectangle has two pairs of parallel segments, and we know that to be true. Any rectangle, even a parallelogram, if we had this shape, would have two pairs of parallel segments. Those are crudely drawn, so don't go by my pictures that I draw. A rectangle has two pairs of perpendicular segments. Well, that's going to end up being false. It does not have two pairs of perpendicular segments. It can't have parallel segments and then two pairs of perpendicular segments. Otherwise, we would not have a rectangle. For 3, 4, and 5, we're just looking at these angle pair types, and this is we reviewed these kind of yesterday when we talked about the quiz. We're going to write down whether it's alternate exterior, alternate interior, or corresponding to describe each angle pair. For number 3, both of those angles are on the interior, and they are on opposite sides of the transversal, so that would make them alternate interior angles. For number 4, we have one on the interior, one on the exterior. They're on the same side of the transversal. They are what we would call corresponding angles. And then finally, with number 5, we have two angles. They're on the exterior of the parallel lines. They're on opposite sides of the transversal. That would make them alternate exterior angles. So the vocabulary today, talking about construction, and geometrically speaking, a construction is some geometric figure that we draw. And it can be using a straight edge or a compass. In most cases, while I'm doing my notes, they'll be freehand as best as humanly possible. And I'm not going to go through number 6 for the English lesson on the noun, verb, and adjective usage of the word construction. So we'll jump into problem number 1, where we talk about constructing parallel lines. And so we have the diagram over here at the right. It shows the construction of line M through point N, and you can see line M is this line here, and it's going through the point N as illustrated or as indicated in the description. M is parallel to line L. Why must lines L and M be parallel? So the diagram shows the construction of a couple of angles that are indicated to us. One of them is angle 1, and you can see that right here in this vertex. So we have angle 1, and we also have, we could call it angle NHJ, and that is seen, let me try to change the color, right here. So there's angle NHJ. So I'm going to write that in. Or you could just call it angle H. The two angles that we've constructed, they're on the same side of the transversal. One is interior, one is exterior, so that means we know that we have come up with corresponding angles. And because corresponding angles are congruent, we can also circle congruent in this description. So now we want to explain why these two lines must be parallel. The transversal makes two congruent angles, and we'll say two congruent corresponding angles. With lines L and M, so we just want to indicate that too. So with lines, if we can be more precise. And so by the converse of the corresponding angles theorem, so by converse corresponding angles theorem. I'm running out of room, so I'm just going to abbreviate now. Lines L and M are parallel. All right. So in that particular case, we did use the converse of the corresponding angles theorem. That is something we have discussed in the past. And it gives us the simple fact that because we have this angle 1, this angle H that are corresponding angles, they are congruent. That means that transversal has to intersect two parallel lines. There's no other way around it. Constructing a special quadrilateral. This is where my drawing skills will be put to the test. We're going to draw a segment and label its length M, and then we're going to construct the quadrilateral ABCD with line AB parallel to line CD, so that AB is equal to M and CD is equal to 2M. The first thing that we want to do is construct parallel lines, or what we're trying to do here is construct parallel lines. If we draw AB, we're going to draw point D not on AB, and then we're going to draw AD. So let me go ahead and first draw AB, which is, you can see it's already given to us, but that's a segment, and because of the little arrows above it, we want to draw a line. So now this segment becomes the line AB. So it continues on indefinitely in both directions. And then we're going to have some point D that is not on AB. And we want to draw, again, it's going to be a line that goes through AD. So I'm going to do that in green here to kind of break things up a little bit. So there is AD. And the length of AB is M. That's given to us in the diagram right down here that they've already started for us. At D, we're going to construct angle TDZ that will be congruent to angle DAB, so that angle TDZ and angle DAB are corresponding angles. And then by definition then, DZ will be parallel to AB. So we need to construct angle TDZ congruent to angle, what was it? I lost it. DAB, sorry. So DAB, we can see right here is DAB. And I'm going to erase those now just because I wanted to point that out. So we're going to construct TDZ. So that means I'm going to put another point on this line. So there's T. I'm going to put a point out here called Z. And let me label that below. And then I'm going to draw this segment. So now I have TDZ. And then we need a side length of 2M. So we want to construct C on DZ. So let's put a point C on DZ so that DC is 2 times M. And that would be from here to here. And if you'll pardon me just a minute, I have to go answer my door. Okay, we're still on 13. And so what we ended up drawing then is this line segment BC. And we see the construction now. So it says constructing a special quadrilateral. What we have is this quadrilateral formed by these segments. So we've created what they're calling, in this particular case, a special quadrilateral, although it doesn't do a very good job, in my opinion, of illustrating that that's what you were trying to go for. But you can see how the quadrilateral is formed by just following the simple instructions that are provided in the example. Problem number 3, we're looking at a perpendicular at a point on a line. And we're going to first draw line EF. And we're going to construct FG so that FG is perpendicular to EF at the point F. So we're going to use a diagram at the right to write each construction step. and then we'll be able to complete this problem. So the first thing we want to do is draw a line and label the points E and F. So that's already given to us. We have the points E and F illustrated over here. Here's E, here's F, and we've drawn, it's this line, I'm going to call it L. So we've drawn L with points E and F. Then for step 2, we're going to have we would use a compass to make the opening the width of EF. And with that compass tip on point F, we would draw an arc that intersects the line twice. So what we would do, we would take our compass, put it here on point F, and we would make this red hash mark that they already have for us, and we would make this other red hash mark over here at H. And so now we have constructed the points E, or we've constructed the point H that is the same distance as E to F, and so F to H is also equidistant. And that means that we have been able to draw the lines, or draw the segment EF equal to FH. And so we know that EH would be 2 times either EF or 2 times FH. And then we would do this again with the compass. Again, they've already done that for us in the diagram here, but they've taken their compass, they've made it greater than half the width of E to H. So you might make that compass opening from here to here. As long as it's greater than half of EH, then you're fine. So they would be the compass opening would have to be somewhere between F and H if you put the point on E. And then we draw that arc above point F. And so we put on point E, we draw the mark that would give us this right here at G that they've already labeled. And then we would put the point on H. We would make a similar mark using the same opening size, and that would give us that point G. And now we have this line that we can draw that is perfectly perpendicular to F, or to the line that I labeled L. We'll call this one M now. I'm not going to finish writing in the steps verbally. The explanation is sufficient. But if you have questions on this, please ask me. A lot of this was just done with a compass prior to us discussing these notes. So it was already embedded into the notes. I didn't draw this on there. They'd already completed it. We just wanted to talk through the steps. So you would draw, all you do is you would make your 2 points E and F. Draw your line through them using a ruler. And then you would mark with your compass the width of EF, and then put your compass point on point F and make a mark to give yourself point H. And so now you have those 2 equidistant points from F would be E and H. And then you just simply make your compass opening slightly more than half the width of the line segment EH. And then you can mark your point G by putting your compass point on E, spinning it here to make this mark, put the compass point on H, make this mark, and that gives you this point G. Draw your line through G and F, and you've created a perfectly perpendicular line just using a compass and a straight edge. The perpendicular postulate: through a point not on a line, there is one and only one line that is perpendicular to that given line. And if we wanted to circle the diagram that models this given postulate, it would have to be this middle one. And we can see that clearly by this right angle that's indicated by the intersection of these 2 lines. Because we don't have right angles indicated in the other 2 diagrams, we know that those lines cannot be perpendicular. And our last example, perpendicular from a point to a line. So we've drawn this line CX, or we're going to draw the line CX, and a point Z that's not on CX, and we're going to construct ZB so that ZB is perpendicular to CX. Underline the correct words to complete each sentence. The first thing we want to do is open our compass to a size that is greater than the distance from Z to line L. And then with the compass tip on point Z, we're going to draw an arc that intersects the line at 2 points. We're going to label the points X, or label the point X, and then we'll place the compass on point C. And with the same opening and the compass on X, we're going to draw an arc that intersects the arc we made in 21. Label the point of the intersection B. Then we're going to be able to draw line ZB, and then using line L and point Z at the right, construct a line through point Z perpendicular to line L. So they've already, we're going to go through these steps now that we've completed the underlining and circling of what's necessary. So they've given us line L and they've given us point Z. So when we put our compass tip on point Z and we draw an arc, let's just say this is the arc that I end up drawing with my compass. So it intersects this line at 2 points. And I will label these points C and X. Then I'm going to place the compass on point C and make an arc below line L. So if I place the compass here on point C and I start to make another arc, I'm going to get this arc right down here. Then I'm going to place it on X, and I'm going to draw another arc below line L, and that gives me this point here. And I will label this point where these two arcs intersect, I'll label it B, and then I will crudely draw my line through that to get ZB. I forgot the last time that I did a set of notes for you all to do a couple of the homework problems. I'm going to remember to do that today. I apologize for those of you that had asked me to do that. In the future, if I make a video and I forget to do that, please just say, hey, you said you'd make some homework questions or show us how to walk through them, and I'll gladly get back on there and do that. I just realized that yesterday when I was talking to the class that I forgot to, so I will make sure that I get on that today. I hope you guys are doing wonderful. Have a great weekend, and I'll be talking to you on Tuesday. Will I see you in person? Yes, I'll see you in person on Tuesday. Most of you. Those of you that I won't, you'll still have the video just like everybody else, and we'll just go from there. So everybody take care. If you have questions, let me know.